So in this lesson, we will do integrals of functions that have an inverse trig function as its antiderivative. So reviewing, last lesson we took the derivative of an inverse function and we got this function. Then so today, if we do the antiderivative of what we got there, it'll take us back. So here we have arc sine x plus c. So that's just, there's no work to do there. You just have to identify this as the derivative of arc sine. Then you can write this. So we're going to be dealing with integrals that require a little manipulation before we can integrate. And here's our strategy. If we identify that this looks like this, then we know we're trying to get arc sine, but we just have to do some factoring and substitution. So our goal is to make this look like that, and now we'll just have something more than just an x here. It'll be a function of x. So let's do this integral. And we know that we want to, here's our goal. So if this has to be a 1, that means we have to factor 4 out of this. And we can check if we distribute 4, it'll take us back there. 4 times this, we'll cancel the 4, and then we'll have 9x squared. So we factored a 4 out, and this can come out of the radical as a 2. Let's rewrite this as 1 expression squared. So that'll be 3x over 2 . If you square this, it'll take us back there. We need to have one thing squared, like this is u squared. The 1/2 can go on the front, and now we do substitution with for 3x over 2. So let's have u, x, u evaluated at a. Let u be 3x over 2, du is 3 over 2 dx, and then we'll multiply by the reciprocal. 2/3 du equals dx. And so over here we have 1/2, 1 over 1 minus, this is u, and dx is 2/3 du. And let's put the 2/3 out in front. The 2 cancels that 2, and we just have a 1/3. And now we've created the integrand that we wanted. This is the derivative of arc sine. So we know this is going to equal arc sine, 1/3 arc sine of u. But we know what u is. U is 3/2 x. And pause the video, try that one. So we want to identify whether this is going to be arcsine, arctangent, or arcsecant. Since it has a radical, we know it's not arctangent. And since it has a number minus x, it's not arcsecant. Arcsecant would have to have a variable there, so we'll go with arcsine. We want arcsine of x, and we're looking for 1 minus u squared. So these are, we're going to focus on arcsine, and we need to make this appear. We need to have a 1, so we need to factor out a 9. The 9 can come out as a 3. We need to make this all one expression squared, so that would be x over 3 squared. And let's do substitution. U equals x over 3, du equals 1/3 dx, 3 du equals dx. We can put the 2/3 in front. X over 3 is u, so that's u squared. Dx is 3 du. The 3 will cancel, and then we have 1 over 1, this expression being the derivative of arcsine. So now we cancel the 3, we have 2 arcsine u plus c, and then we substitute for u. U is x over 3. So here we might not recognize a pattern for an inverse trig integrand, but because of that x, maybe that x throws it off. So sometimes with substitution you just have to try it and see if it works. Since we don't have a radical in the denominator, let's focus on looking for arctangent. That means we're looking for 1 over 1 plus x, and 1 over 1 plus u squared. We need to make 1 plus u squared appear in the denominator. So we don't have to factor, we already have the 1, and we can write that as x squared squared. And we're ready to try substitution. We want that to be u to be right there, so we'll say u equals x squared. Du is 2x dx. Du over 2x equals dx. Alright, x squared is u. Dx is du over 2x. And the substitution will work because now we can cancel the x's, and that 2 can come out as a 1/2. And we've created the desired integrand because this is going to give us arctangent. So we have 1/2 arctangent of u, and we know u is x squared. Pause the video and try that one. Since there's no radical, we'll be looking for inverse tangent. So we know we're looking for 1 over 1 plus u squared, and we have a 1, so we don't have to factor. All we have to do is rewrite that. And substitute. So 3x is u, dx is du over 3. And that's what we wanted, and that's going to give us arctangent. And u is 3x. Alright, and now let's do a definite integral. So we can use all the same steps, so we just have to remember to change from x values to u values. We have to identify our goal here. We see square root, so it's not going to be inverse tangent, and it's a number minus x. So let's look for 1 over radical 1 minus u squared, and that's going to be arcsine, or give us an arcsine. So we don't have a 1. That means we have to factor out a 25. So 25, 1 minus x squared over 25. If you distribute 25, you get 25. Distribute 25 here, and you get x squared. So we know it's correct. And that can come out as a 1/5. We also need to write this as one expression squared. So x over 5 squared is x squared over 25. Now we can choose u to be x over 5. du is 1/5 dx. 5 du dx. We also need to find u evaluated at 5 and u evaluated at 0. So let's put a 5 in there, put a 0 in there. Those are the new limits, u values. We're going to go from 0 to 1. Alright, so u is replacing x over 5. There's the u. dx is 5 du. This would cancel the 1/5, so we can do that. And now we have arcsine as the antiderivative. So this gives us arcsine of u evaluated from 0 to 1. Arcsine of 1, arcsine of 0. Find the angle that has a sine of 1. What angle has a sine of 1? And that's going to be pi over 2. And which angle has a sine of 0? That's 0. So we get pi over 2. Alright, pause the video and try that one. So we have to identify which inverse trig function we are working towards. We don't have a radical, so it can't be arcsecant and it can't be arcsine. Maybe it can be arctangent. So we know that for arctangent we're looking for 1 over 1 plus u squared, and since even if this wasn't addition, we could always switch the order and make one negative or manipulate it to look like that. So let's start just by switching the order. And we're working towards making this look like that. Since this is not a 1, we need to factor out a 2. Two times 1 is 2. 2 times this cancels the 2, and we'll be left with 3x squared. Then let's put that 1/2 in front. And we need to make this one expression squared, so that has to be radical 3 over 2 x squared. And we can check if we square this, it'll give us 3 over 2 x squared. That'll be the same, so we know that's correct. Now we can substitute u equals du is radical 3/2 dx. Let's multiply by the reciprocal, radical 2/3 let's evaluate u at radical 2 and at 0. So u evaluated at radical 2, we're going to put a radical 2 right there. Radical 3 over 2 times radical 2 over 1. Just write that as a fraction. That means we're going to get 3 times 2 over 2, and we get radical 3. If we put a 0 there, we get 0. Okay, now we substitute. So instead of going from 0 to radical 2, we're going to go from 0 to radical 3. And we have 1 over 1 plus u squared. And we have in place of dx, we'll put this. And let's just put all that in front. We have, this will give us arctangent. So we have, let's just break that up. So I have the 1/2, then I have the radical 2, radical 3. This is going to be arctangent of u from 0 to radical 3. And let's go ahead and substitute. So we have radical 2 over 2 radical 3. Arctangent radical 3, arctangent 0. Find an angle whose tangent equals radical 3. So we're saying tangent of some angle is radical 3, and that would be, here we have y over x. The y value is radical 3, the x value is 1. So this must be a pi over 3. And we have to do arctangent of 0. Tangent of some angle equals 0. Where do we have a y value of 0? That's going to be here. So the angle is 0. Arctangent is 0. So we just have to rationalize the denominator. Let's multiply numerator and denominator by radical 3. We get radical 6. And then this will give us a 6. Pi over 3. So we get pi radical 6 over 18. Okay, and we'll stop there.